This is lesson 7, and I'm going to dedicate this to natural light, the position of the model with respect to true north. I'm looking at a satellite image of the building, and the facade of the building parallel to School Street. True north in the image straight up and down. School Street facade is about 20 degrees from I'm going to say that it's 20, right? And that's the angle between School Street as if it were aligned to true north. So this is the way we would like School Street to be lined up. And the difference is the difference in that angle. 20 degrees. The revit model is compounded by the fact that School Street in our revit model is tilted away from true north to the west. So we have to add in that angle. Let me draw a couple lines to illustrate that. So here's a line perfectly horizontal, and the angle away, the angle that School Street is tilted away from this horizontal right now can be measured as 4 degrees. The angle that we need to add is 20 degrees. In Revit, the site plan shows you, and I've drawn a line, and I've drawn a north arrow symbol. If true north were straight up and down, and School Street were perpendicular to true north, that would be the orientation. In fact, true north, according to the diagram here, is a difference of 20 degrees if School Street were horizontal, parallel to the horizontal line that I've drawn there. So north is actually this direction, 4 degrees plus the 20 in that drawing, so that would be 24 that way. The site plan reveals the site project location, and I can set the angle to true north here. And what I'm doing here is typing in a value of 24. The diagram, to add some meaning to this diagram in the drawing, the sun diagram says, okay, the sun comes from the east, it's correct, it starts here somewhere early in the morning and travels around this way. So presumably morning light moves in that direction, it strikes the building in a certain way, generates a pattern of shadows which we ought to be able to match. So I'm going to set my sun. I set my sun position to true north. I'm turning shadows on, and by default, Revit sets the sun from either the top right or the top left of the model, which is not very meaningful in terms of real position of the sun. So you have to change the solar situation to something like, say I set it to spring equinox and made the time 12 p.m. So we can see that at 12 p.m. the sun is typically due south, and we've correctly set it because the shadow cast is pretty much parallel to our north arrow. It's aligned with that north arrow. So we have the correct position for north. Now, but what else? Let's see, let's test our, let's look at Google Earth. How convenient. We're looking toward down the street, and we have a clock on the wall here that's telling us it's 9:22, presumably a.m. Right? So we go to our model. Go to a 3D view. And let's set the sun, spring equinox, 12 p.m. Let's see what happens at 9:22 a.m. I've made a deliberate mistake, which you ought to recognize, and you will in a minute. I'm going to 9:22 a.m. Okay, so what's wrong? Why isn't this matching? We have a handful of citizens here whose shadows or cast are not quite aligned. 9:22. Well, the reason being, if we travel around here, so those angles are almost straight up and down with School Street. Notice these people are dressed very scantily, and the sun is at a pretty high angle here. So what's wrong with the picture is that we did not, it's not a spring solstice at all. It's more like summer. And in fact, Google Earth is saying the image is captured in July of 2017. So we have to set the sun not to spring equinox, but let's quickly, summer solstice, 7/21. Does it give a date? It just says July, 9:22 a.m. So let's see what happens. 9:22 a.m. in July. Let's apply that. And we're still not getting the same pattern, and it looks like I think that the difference is going to be the daylight savings, because if we set it back an hour to the 8:22 a.m., notice we have the high angle of sun pattern on these columns facing School Street. And if we look here, I'm going to point to about that direction. That's what we have going on. So give or take an hour, that's pretty much our sun position. And you can, there's lots of things that you can do with respect to simulating. Revit allows you to conduct a solar study. If I click sunrise to sunset, I forget how to activate this animation. One day solar study intervals of 1 hour. Preview. Play. So I can move a frame at a time. Different times of day. Let's make sure that we have the right sun settings. 10 a.m. to 4 p.m. Okay, we want to be closer to the date that we said. Let's set it to July. 6 a.m. to 4 p.m. Okay. You play the animation, there it goes. It moves right past us really quickly. But I can move it one frame at a time, and it's telling me frame 8, 9, 10 is 3 p.m. Let's go back. 12, 11, 10 a.m., 9 a.m. And you can see that is about what we're looking at actually on School Street. Anyway, I don't want to dwell very long on this, but we have at this point a high degree of confidence that our sun angles are correctly set. In the next lessons, we'll look at the model from the interior. We'll cut some plan and section views and start to organize the drawings that we generate from this model.